Welcome to our Google demo session at SAP NOW 2021 in Switzerland. This demo introduces you to a visual inspection scenario built on Google Cloud Platform and integrated with SAP Manufacturing Solutions. This demo was prepared with SAP and together with our partners Vabion and ITPC.
So my name is Michael Dietz and I'm a custom engineer for the topic of SAP on Google Cloud. So that means I support customers with bringing the SAP landscapes on Google Cloud, but also add a lot of innovation pieces. And today I want to demonstrate an example of a manufacturing company that has built together with us and together with SAP a visual inspection use case that enables them to automate their kind of quality inspection processes. So what are the typical challenges that company talk to us and explain to us? So in the first one is that today, if you want to have a kind of machinery for traditional classical inspection, they're usually very expensive. So they can cost up to millions of dollars per device. And that's for a very special use case of doing a visual inspection. And we are more looking into a machine learning based approach to do a more, I would say, general purpose visual inspection. But even then, many companies have challenges to find the right resources, find the right experts, machine learning experts, data science experts that then can help them to build up a model from scratch that supports them in doing visual inspection using ML. And the third topic with machine learning is that you need a lot of data. So clearly, if you want to build a model from scratch, you need to have masses of sample data that you are leveraging to train a new model. And that's exactly what we address with a certain kind of core product that we have in our machine learning portfolio, which is the so-called AutoML solution. So AutoML on the next slide gives us an overview of, or gives us the ability to train a custom machine learning model based on only few data points that we bring. And let's have a look at the overall picture of a visual inspection using that kind of AutoML functionality on Google Cloud. What we get started with usually is to acquire images. So getting images, doing some kind of a pre-processing of images, and then also adding a human in the loop that does the initial data labeling. Data labeling means I have a bunch of images and I say, is that an image that everything is all right on, or is there a defect on that image? And just by saying, hey, this is this defect, this image has that defect, and things like that, that's the labels we need to then put the data into an AutoML vision training. So once we have that, and we will see that in a later demo, we are going to hit the button and say, please train a model for me. And AutoML Vision then does the magic and does a lot of very advanced machine learning technologies like transfer learning. And therefore, it uses a feature engineering approach. It gets started with finding the right models, the right architecture for a neural network model. And it then at the end does hyperparameter tuning to really find the best kind of configuration of hyperparameters to have the best outcome for your kind of use case that you're training for. And then finally, when the model is trained, you have multiple options. So you can either run it in the cloud, you can run it in the container and put it on Anthos, which is something you could run on premise, for example, or you could even run it on an edge device. So there's an export functionality to put it onto a format like TensorFlow Lite and then install it on a Raspberry Pi, for example. And that's a very powerful kind of way how you then bring it back into the manufacturing process and really apply that model directly in the shop floor. So having that, let's hand over and look into the demo. Good. So what we see here is the Google Cloud Platform console. So that's the main UI you interact with to get started with Google Cloud. It has access to all different kind of products on the Google Cloud. So for example, a lot of things about compute, like starting your own VM, running a Kubernetes engine, databases, networking, a lot of operations pieces to support developers and operations teams, tools for the developers. And then if you scroll a little bit more down, we have a lot of big data, and then finally the artificial intelligence topics. And in the artificial intelligence space, there are a lot of different disciplines and topics that we address. For today, for the visual inspection case, we look into the piece of vision. So vision is the capability of leveraging an existing data set with labels to train your own kind of model that you want to predict at the end. And that's what we use for visual inspection. So let's have a look in the first one. which is a simple example of a visual inspection case where we have these kind of components that we look into. And these components are quite simple, but they can have 4 different error classes that occur here. So this is one that, let's have a simple look at this one. So you have that plastic cap, and one error class, for example, could be that the entire plastic cap is missing. That's one error case. Then another error case is with regards to the screws. So you see here that there are 3 screws, one on the bottom, one on the left, one on the right. And in this example, the right one is missing and the bottom one is missing. So 2 error cases in one. And that's the kind of use cases and the errors and defects we want to look into, and we want to train a machine learning model that understands that. So using AutoML Vision, as I said, it's quite easy. You bring these images, you define the labels for these images. So some kind of human says, okay, that image has is everything is good. That image has the left screw missing. That image has a right screw missing. So you define the different kind of defects that you see here and define them as labels. And with that, you then can go into the next step and do a training of a machine learning model that's specific for your kind of use case, learning your defects for your part and your assembled kind of material you're looking into. And the big benefit of that is we don't need masses of data. So we do a training of that model we look into here based on only 189 images that we use for the training. So that's very, very few data compared to if you want to build a machine learning model from scratch. And that's the big advantage of AutoML Vision. So let's start a training. And as I said, that's super easy. So what we do is we go in and say, we want to train a new model. And then it asks me how I want to train the model. Do I want to train a model that's ready for the cloud and only deployed to the cloud, and you can use it for online predictions via an API? Or do you want to have a model that you can export and put onto an edge device? So for now, let's choose the edge device piece. And we go in and say we want to optimize that edge device model for a certain direction. So either we want to optimize it for higher accuracy, but then also we see that the size of the image, the model gets bigger and the latency gets bigger, or we want to optimize more for faster predictions, which means the latency to do prediction is getting lower, but also the accuracy is getting lower in that case. So that is a trade-off we have to decide based on our particular use case that we want to achieve. So let's go for faster predictions. And then the third and last step is we define a number of node hours that how long we want to train the model. And basically node hours is, there's a price for node hours. So basically at the end, you define how much money do you want to spend and how much time do you want to spend on training this particular machine learning model. In this case, I just say 3 hours, 3 node hours, and then I start the training. And now that magic of AutoML starts, right? It does the feature engineering, it does the model selection, it does the transfer learning approach, and it ultimately does the hyperparameter tuning to really find the best model that's useful for your kind of challenge and your use case, and basically the data you brought to it. So let's check one of the models I have already trained here. And this is a model that shows me, and the evaluation page basically shows me a lot of insights about that. So it shows me a little bit of curves about recall and precision. And it shows me, for everybody that's not a machine learning expert, it shows me confusion matrix. That's a lot easier to understand. So the confusion matrix tells me of how often does it do an incorrect kind of prediction. So in that case, what we see here is giving the example of left missing. If the image shows a left missing kind of situation, in 100% of the cases of the validation data, the model predicted that left missing is seen here. So 100% of the cases, the model was right. But the only issue we see here is with right missing. So right missing, in this case, only has 38% that's predicted correctly. And 50% of the cases, it predicts button missing, and 13% it predicts left screw missing. So for the right missing piece, it's still quite inaccurate. What we usually do is then to go back and usually find more data, so that we add more data to it, because more data ultimately helps the model to better abstract kind of what it wants to learn or what it should learn, and then it gets ultimately better. That's one approach. And sometimes it also helps to delete some images. So if there are images that are misleading, that are not that detailed, where the lighting is bad or something like that, that's exactly where also deleting some images and data points can help a lot. Then in the last step, we want to use that kind of model. And as I said, there are two options: either use it in the cloud or use it on an edge device. And here we have both on the same page. So we can either go ahead and can say we want to use and deploy to the cloud and then get an API that we can use to interact with, or we can go in and say we want to use it on an edge device. Let's test the cloud variant first. So here we have a button, test your model, upload images. So I can take an example image, have an image of a left screw missing. Now it runs through the API, and the API ultimately gives me the feedback that the left screw missing is the predicted kind of case that the model sees here. And it is quite confident, so that it has a probability of 92% that left screw is the right kind of class to predict here. So that's already quite good. So test worked, and now we can go into the next step and say, hey, let's download it in a certain format so that we can deploy it to an edge device. And there are various formats. So for example, TF Lite, TensorFlow.js, CoreML. So CoreML is the iOS specific kind of format. So we could take that immediately to an iOS device and then run it there. A container that we can deploy, for example, on Anthos. And then the last piece is a so-called Coral package. And Coral is referring to a set of a family of hardware accelerators that Google has built and Google is selling that are basically the so-called edge TPUs. And these edge TPUs are devices that help to do a quicker inference on accelerated inference on an edge device. So you can, for example, connect it to Raspberry Pi, and then the Raspberry Pi uses this additional hardware to speed up the inference. And that are the main options to run it directly on an edge device. So what we usually do also to additionally test and get a little bit more insights into the quality of a model, we do add some kind of explainability to it. And the term AI explainability refers to all kind of mechanisms and technologies and techniques to make machine learning better understood by humans. So usually or very often, a deep learning network is something that's more observed as a black box and seen by humans as a black box. And we try to overcome this by adding some mechanisms to really visualize what is the important parts the model is learning from or is taking to predict a certain outcome. So long story short, what we want to achieve in that particular case of visual inspection is we want to see what kind of pixels the machine learning model takes in order to come to that prediction that the left one is missing. And there is a little example, but that example requires me to run the API using the command line tool. And in Google Cloud Platform, you have a command line always available, which is the so-called Cloud Shell. So let's open up the Cloud Shell and let's do a simple call to our AI API to say, we want to have a certain image and we want to have it explained. So that's that call here saying explain. And what comes back from that is a base 64 encoded version of the image. So that's the huge string that you see here. And if I put that back into be an image, I see that it has a certain overlay. And that is exactly what we are searching for. That overlay tells us what kind of pixels had been predominant in predicting the outcome that this one is left missing. And we see that it clearly focuses on this left area where the screw should be, but it's not there. So that it came to the prediction that the left screw is missing. And that additional layer of explainability is something that helps us to understand the model better, and then ultimately having it as an additional check before we then take the model in and take it to the edge side and really run it in the production line. And that's what we are doing. So having said that, we are done with the demo of today. Just to summarize, the visual inspection piece is a very interesting kind of use case, and AutoML Vision is a super helpful tool that makes it easy and without any kind of machine learning knowledge to build such models and to really then at the end integrate it into the production line, into the real manufacturing processes by using that export functionality and things like that.
With that, we've reached the end of our demo session. If you have further questions or would like to get more information, please visit our virtual Google partner booth. Thank you very much for watching this demo and have a great SAP Now.